So today we are going to build memory folder. Now there are three files inside memory folder. So the first one is arena.c, pool.c and memoryutils.c. Now each file has more than three functions. So let's start with the arena.c. But before that, let me just create the folder memory. Now it's going to be outside. Yeah, perfect. So now what I have to do is, let me just create arena.c. Let's include, the first thing is common.h. Then we will also need allocator.h. Okay, so let's allocator.h. Now these are the two header files we had to include. So now let's check what other things. So the first function which we have to build is arena.c. Now you can check the parameters and return value in here in header file. That's why we've declared it before. Yeah, here we go, arena.c. So let's copy it from here. Let's paste this here, and yeah, like this. So the first thing is we have to check the capacity. Okay, but before that we have to so this capacity is not of the arena which we are going to create. It's about the memory which is going to be inside that. Okay, so the first thing is we need to create the arena itself, because that's where our memory is going to be. So how we're going to do that? Malloc, and we have to give size of. Now you can either do something like this, arena. Now what we are doing here is we are giving it the struct itself, or you can give, so this the yeah, so something like this, arena. So now they both mean the same thing. You don't have to worry about that. So I'm going to do something like this. So even if later I change something like from here, instead of doing arena, if I did something like pool allocator, now I don't have to change it over here. So that's a more reliable way, I guess. After that, I have to check. Okay, let me just do this here. I have to check if arena is null, then we have to return null, because we can't go forward then. So after that, what we have to do now, we have to check the capacity. If capacity is equal to 0, then return. Should I return null, or should we make the capacity 1? What should we do? For now, let's return. If later we make some change of plans, then we will change it over here as well. So after that, I have to get the memory, so it will point to void memory malloc, and then I have to give the capacity something like this. After that, we have to check if memory is equal to null. Then the first thing which you have to do is free arena, because then there is no use of keeping arena. It will leak. It will become a leak of memory. So yeah, like that. Then I have to return null, like this. But if we've got the memory address, in that case, I have to check what's values are there inside arena struct. So we have to save memory, capacity, and the offset. Yep, let's do that. So what I have to do is arena, then inside memory I have to do something like memory, then one more thing, that is uh, arena capacity will be equal to capacity, and then arena offset, which will be equal to 0, and then I have to return the arena. Yeah, so this is what arena create is going to be doing. Now what we can do here is we can reduce the lines of code here, but let's just keep it simple, because in reducing the number of lines means making it complex. so it becomes hard to understand, and we don't want that. So yeah, we're going to prefer maximum lines of code. Now the next thing is we have, so let's see what we have next. We have arena alloc. Now I haven't explained you like what this does. So instead of calling malloc every time we want something, what we're going to do is we in the beginning we are going to get a huge amount of memory, and then we are going to give chunks from that memory as needed to the program. So that's what we are going to do. Now what it does, it reduces the work. After that we have, yeah, arena alloc. What it returns, I think, yeah, it returns void. So it returns address. So arena alloc, and then so what it takes these values. So let me just copy. So arena size and alignment. So it takes pointer to arena, it takes size, and it takes alignment. Just a second. It takes alignment just like this. Now the first thing which we have to do is we have to verify, we have to check, validate all these things. So how I'm going to do that? So let's check arena. If arena is equal to null, or maybe size is equal to 0, or maybe alignment is equal to 0, in that case I have to return null. Now yeah, once this is done, next thing which we gotta do is arena allocates a block of memory. Okay, so I have made this thing here, let me just show you. Yeah, so what we have to do here is allocate memory from arena memory. Okay, check parameters, check memory. Yeah, we gotta check memory as well. So yeah, so as you might remember from the previous function which we have built, we have added this memory inside arena. Where is that? Yeah, here you go. Now we have to check that here before allocating chunk of that memory. So how I'm gonna do that is, so if arena memory is equal to null, in that case I'm going to return null. After that we have to check if alignment is power of 2. If the alignment is not power of 2, we won't be able to get the aligned address. So yeah, we're gonna stuck later. So now before aligning the address, we got to check if alignment is perfect. So I'm gonna do that. If alignment, okay, alignment and operator, alignment, okay, -1. If, okay, just a second, I fucked up somewhere. Yeah, it's not like that, it's like this. Yeah, so if this, just a second, if this is not equal to 0, that means the alignment was in power of 2. So in that case we have to return null. After that what we have to do, we have to get the current address, and we have to get it as pointer to, no, we have to get it as integer. Okay, so and then we have to build the align address, and yeah, stuff like that. So what I have to do here is, it's going to be, now I'm going to do some define it. Okay, in common.h, where we have defined, yeah, here. Okay, so we have already defined it. So you have to do this, just a second. Yeah, you have to do this. Okay, you might not get it first, but yeah, let me just show you now. So you, what was that, uptr? Okay, so it is unsigned integer pointer type. So I've just made a shortcut of it. It's going to be current address. Let me, I'll explain to you what we are doing. Align address, and it's going to do, what we're going to do is ptr, yeah, something like this, and then we are going to be converting the arena memory. Now why we are doing this, why we are converting the memory from pointer to integer, in order to perform bitwise operations with an address. Okay, we gotta convert that address to integer type. That's when we'll be able to make bitwise operations with it. So that's what I'm doing here. Now we'll do bitwise operations here. So we will be getting something like aligned address. So there is a formula to get aligned address, that is current address plus alignment minus 1 and operator. Then we have to reverse the bits, and then here we have to do alignment minus 1, something like this. Now what this will do is it will give us the aligned address. So once we've got the aligned address, we have to get the padding size t padding, which will be something like align address minus current address. Okay, so now we've got the padding. So once we've got the padding, what we have to do, we have to get the total size. So size t total size, which will be size plus padding. Okay, now we have to check if now we have to check what do we have to check. Let me just think first. Okay, now what might happen, we have to check this before adding it. Yeah, so we have to, before adding the padding in size, we have to check whether like size t cannot store, there's a limited amount of integers, numbers size t can store. So if yeah, so if we exceed that amount, then what will happen is it will shrink it, so we don't want that. So for that, what I'm going to do is, if size is greater than size max, so there is something like size max, there you go. So what we have inside size max is the maximum amount size t can store. Okay, so now what I have to do is I have to do size max minus padding, and then we have to check it. If it's greater than size, in that case we have to return null. Otherwise we have to add size and padding together. And then what I'm going to do is we have to increase the offset. Now how am I going to do that? So we have offset inside arena offset, just a second, offset plus equal to the total size, and then I have to return the pointer. So I have to return the line address, but we have to return it as pointer to void. Okay, as you can see here, we made it integer, so now we have to again make it address. So that's why what we're going to do is we are going to make it pointer to void like this. Let's see if it did everything proper here. Okay, so build a line address, get padding, create total size, check total size plus offset. Okay, gotcha. So we also have to do this after, like here. Okay, so here what we have to do is we have to check if total size is greater than size max minus arena offset. Okay, our total size plus offset, we can't do this. Yeah, we have to check that. Yeah, so you might remember where is, yeah, we have capacity inside Karina create. Okay, so let's say if the capacity is, for example, 10. Now when if the capacity is 10 and here total size is, let's say in total size we have 10, now we can't increase it, right? Because we only have, let's say our total size is 11, so we can't increase offset because we don't have that much byte into memory. So before doing it, we have to check if plus arena offset, if it's greater than capacity, then we have to return null, otherwise we are good to go. Now we have capacity inside arena, so yeah, like this. and we have to remove this. So we've built arena alloc as well. Now the next function which we have to build is here. Just a second. Arena reset and arena destroy. Let's do that. I don't know. Yeah. So I think both functions are very small functions. So let's build them. Void arena reset. It's going to have pointer to arena, address of arena. Okay, now we don't need to check anything, we just okay, if arena equal to null, then return null. Otherwise what we have to do is we have to make arena offset equal to 0. Now yeah, so now here you're going to get confused. Now you'll say we haven't freed the memory which we had before, so how can we reset it? Okay, let me just tell you that, like, let me explain you like this. So let's say we have something like this in memory. Okay, so let's say we have something like this in memory. Now we don't have to free it. Okay, we can, like, let me just show you, we can just reuse it without freeing anything. Okay, so what will happen is when we'll reuse it, we will just change the values we are using. Okay, something like this. What the fuck? Okay, the values inside will change. Okay, you don't need to free, so we are just making offset to 0 and saying you can start using the memory again. Now though, when you reuse it, the old memory will be gone, and you will save the amount of work that it will take to free the memory. So like if we have hundreds of millions of bytes, then you can't free each one, right? So we are not freeing it, we'll just reuse it. So that's what we are going to do, and let me just remove it. Okay, now what we have to build is arena destroy. Yeah, arena destroy. Let's go. Now arena destroy is doing something different, so we have to check if arena is equal to null, then return null. Otherwise we have to free. Now here we are destroying it, not resetting it, right? So that's why we are using free here. So the first thing we have to free is the memory which we have inside, and then we have to free the arena itself. So if we do this, so if we do the opposite, if we freed the arena first, then what will happen is we won't have the memory address, and yeah, that is the leak of memory, so we don't want that. So we are freeing the memory first and then the arena itself. So like this we have completed the arena.c. Now you can see I'm not pushing it because I have already a backup project where I have added all the comments and all that. So yeah, before getting this project, if you go to the GitHub, so you'll get future lines of code as well. So yeah, I'm not gonna push it. You should actually. So the next thing we gotta do is, just a second, now we have to build pool.c. So let me just create that file, pool.c. Now what we have inside pool.c: pool create, pool alloc, pool allocation, pool free, and pool destroy. Let's go. Let's start with pool create, which takes pool allocator and returns pool allocator and takes object size, count, and alignment. Let's go. Let's go. Now what I have to include here is include common dot H. I think it's fine. I don't need to include anything else. No, we need to include the allocator because that's where we have got um, the pool allocator struct. So yeah, we're gonna need that. Include allocator dot h. Yeah, there you go. Now what we have to do is it's going to return pool pointer to pool allocator. Pool create, is it pool create? It's pool create. Then object size, we have object size, we have object count, and we have alignment. So alignment is also size t type. Alignment, perfect. Now we have these three parameters arguments. Now we have to, let me just go to my obsidian. Now what we have to do first, okay, so we have to check the parameters. Yeah, let's do that. If arena object size is equal to 0, or object count is equal to 0, or alignment is equal to 0, in that case we have to return null. Okay, so I'll just, okay, here we don't have to return anything because it's a struct. Okay, so yeah, change these things because we can't return anything. It's a void. Not here, actually, here and here. Yeah, so you should change these as well. I just remembered that over here. So yeah, then we have to check if it's a power of 2, the alignment is power of 2 or not. So yeah, I have to check that as well. So I'm gonna check that. Alignment and operator and alignment -1. If it's not equal to 0, in that case return null. Okay, now what we have to do next, then we have to create the pool and check the pool. Okay, now pool allocator, pool malloc, and then size of pool, and then we have to check it as well because we can't just dereference it like that. What I have to do, pool, if pool is equal to null, then return null, buddy. Okay, after that we have to check object size will not break by adding alignment. Okay, align object size. Okay, understood. Yeah, yeah, I got that. So what I have to do is, if object size is greater than size max minus alignment, okay, in that case we have to return, okay, we need to free the pool and then we have to return null, otherwise we will get the aligned object size. And how we are gonna get that, as I told you the formula before, aligned object size will be object size plus alignment -1. Then we have to use the AND operator, then reverse the bits, and then alignment -1. Okay, now here we'll get the aligned object size. Then what we have to do, then we have to check total size. Okay, check total size will not leak. What the fuck is total size? Yeah, understood. you have to check the total size will not leak. So yeah, aligned if okay, if aligned okay, what the fuck, aligned object size is greater than size max divided by the object count. In that case, if it's greater than, then it will leak. So in that case, we have to free the pool, and then we have to return null again. So yeah, I've checked total size will not leak now. The next thing we have to do is create memory and check. Yeah, let's do that. So I guess it will be, yeah, it will be void. It will point to void. So memory, then we have to do malloc and pass the total size. Yeah, we have to get the total size as well. Total size, which will be object size, align object size multiply object count. Okay, and here we have to give total size. Yeah, perfect. We have to check if memory is equal to null. In that case, free the pool and then return null like this. Okay, and the next thing, now we have created the memory, we have checked it as well. For each object, change pointer to free block. Okay, now what we have right now inside memory is something like this. So we have just whole huge memory block with, let's say, 100 bytes. Now what we have to do is 100 bytes, and let's say we have 10 clients here. Okay, 10 clients means 10 clients. Okay, now let's say according to 10 clients, so each client will get 10 bytes. So we have to change, so let's say something like this. Okay, for now what we have to do is we have to divide this 100 bytes into 10 bytes, and then we have to make it as pointer to free block instead of pointer to client or void. It's not pointer to client, it's pointer to void. Okay, now this is something you, if you didn't understand, if you didn't get it, so you have to just understand it yourself in depth. Okay, for size t, I is equal to 0. Okay, if I is less than what, object count, then we have to do I plus plus. Okay, now what we have to do is we have to get the address. Yeah, we got to get the address. So before that, yeah, so let's get the, so it will, as I said, it will point to now free block. Okay, block, and then what we got to do is yeah, it will point to free block, something like this. Now I can't just add memory because memory is pointing to void, and these are all integers. So first I have to make it pointer to integer, right? U8, yeah, U8 would be good. So U8 and U8 base, let's call it base, and then I have to make it pointer, I have to make it, yeah, pointer to, just a second, yeah, I have to make it pointer to integer, an integer, and then we got to do something like, what do we have to do here? Let me just think. Base says memory address plus I, yeah, and then okay, now yeah, okay, we have to get the current address. Yeah, so now the first address will be something like base plus I multiply the object size, align object size. Okay, something like this. I'm a little confused here. Aligned object is size t, and no, total size, I guess. not total size, aligned object size. And base is, I think it will work. Yeah, I think it will work. So create memory for each object, change pointer to free block, add size. Yeah. Now what we have to do is, let me just check. Yeah, so it's recording. So now what we have to do is, we got the current address. Okay. Now what we just did is, like, let me just show you. Now before it was like something like this. Now we just created, okay, it's just a second, why I've got the arrow. Let me just group them together. Before it was like this. Okay. Now after, we have just made a single free block here. Okay. Now for 10 bytes we have made a free block here for 10 bytes. Okay. Something like this. Let me just make it small. Yeah, for 10 bytes we've made a free block here like this. Now in free block we have, yeah, so for free block we have something like, let me just go to arena allocator dot, yeah, where our free block is. Yeah, for free block we have size and next. So size is 8 bytes and the struct itself will be 8, so it's total 16 bytes. But let's assume it's 2 bytes. Okay, let's assume 2 bytes. So what will happen is, we now total have 10 bytes and the allocator and the free block is 2 bytes. So we just gave the first 2 bytes. Okay, something like this, and the other 8 bytes. So now 10, there will no longer be 10 unused bytes, so other 8 bytes will be unused. What will happen is, yeah, we have just created a free block. So now free block size is, let's assume 2 bytes. So here we have got 2 bytes. Okay, and the other 8 bytes will be unused, and in these 2 bytes we have something like this. We have size inside it and we have the next, and here the other 8 bytes is unused, and this will be same, and this will be same for the next. Okay, let me just show you. Okay, this will be same for other parts as well. So we will be doing something like this. We will be having 10 parts like this. Okay, now these are not 10 parts, but yeah, something like this. We'll be having 10 parts. We'll divide this 100 bytes into 10 bytes part, and yeah, and for each part the first 2 bytes will have size t and next, and then the other 8 bytes, remaining 8 bytes, will be unused. So later so what the agenda here is, we have to keep the track of all the 100 bytes as well, and we can like allocate each block as well, right? So we can reuse it. You'll understand it later. Let's go to code. Okay, pool.c. Now we have got the block. Inside that, as I said, I have to now add the size, and size will be aligned object size. Now the next thing we got to do is, we have to add the next address, but we only have to add next address if the object is not last. Okay, now what we are doing here is, we have made a chain like this. We are making a chain of memory like this. Let me just show you something like this. Now uh, each memory or each block has size and the next. Okay, and next is means it points to the next free block. So it's something like this. So each free block points to next free block, but there is last free block which can't, there is no other free block next to it, right? So it can't point to anything. So that's why here we have to give null as next. So that's what we have to check here. So if I is equal to object count minus 1, in that case we have to give block next as null. Okay, else what we can do is else we have to get the address, the next address, which will be something like u8. Okay, next address, and it will be base plus I. So I is the current object, right? But we want the address of the next one, so we will do I plus 1 multiply aligned ob aligned object size. Okay, so once you've got the address, what we have to do is free block, okay, block next, and then we have to convert that. Now it's pointing to integer, so we have to make it point to free block. So it will be do something like this, and then next address. Yeah, perfect. Let's see if I'm right or wrong here. Okay, for each object free block add size, and if last object add next null, else add next address. Yeah, so we have added that. Then fill pool. Okay, so what we have inside pool, let's check. Where is pool allocator? We have to add memory, free list, object size. Okay, so let's do this. Pool memory. So memory will always point to the first block of the memory. Okay, memory, something like this. Then pool free list, which will have the first block. Yeah, so yeah, I was right. We have to store the memory block, its address itself, but we have to convert it to pointer to free block. Okay, like this. Then we have object size, object count, and alignment. Object size will be equal to aligned object size. Pool object count will be equal to object count, and then we have pool alignment. Okay, just a second. Alignment, which will be equal to alignment, something like this. Okay, now we have filled everything. Now we have to return the pool allocator itself. So now I'm going to return the pool. Perfect. So pool create function is also done. You should push it to GitHub. You should commit it. The next thing which we got to build is, I have to come here, pool alloc. Okay, pool allocator. Okay, let's do that. Void pool alloc. It gets the address of pool allocator. Now the first thing is we have to check if pool is not null. If pool is equal to null, return null. Okay, after that we have to, what we have to do is check free list. Okay, we have to check that as well. Get the free list first block, and yeah, understood. We have to check pool if free list is equal to null, then we have to return null. Otherwise what we have to do is we have to get the block, free block. Now it will be something like this, block. Okay, and then we will have the free list pool. Okay, it will be equal to pool and the first free block, something like this. Now the next thing we have to do is we have to change the address. So I have to check one thing. Where is pool alloc? Okay, it returns pointer to void. Okay, what we have to do now is we need to change the address of the free list. Yeah, so in pool we have to change the free list address to the next uh, free block. So the next free block, so as you might remember, so we have the next free block address over here. So each first free block has the address of its next free block. Okay, so we have got the first free block, and then we have inside that first free block we have address of next free block. So we are going to save that next free block address inside free list before freeing this before making this block as pointer to void. Yeah, so not bull, I not bull, pool. Okay, pool will, okay, no, not pool, actually block, and then next something like this, and then I have to return as pointer to void the block, something like this. So pool alloc is also done. The next function which we have is pool free. Pool free, yeah, pool free. So it's going to return nothing. It's going to have pool and pointer. Yeah. So yeah, let's build it. We have pool. Okay, it's going to return nothing. Pool free. Pool allocator. So it's going to have pointer to pool allocator, and it's also going to have the pointer to void. Okay. Now what we have to do is first we have to check if pool is equal to null or ptr is equal to null and return null. Else else what we have to do is we have to make this pointer to void to we have to make this address which is pointer to void to address pointer to free block. So yeah, something like this and something like this. Yep, so now it's pointed to free block. Then we need to do something, that is we have to store the block size. Size will be pool object size, something like this, and also the address. So block next will be equal to pool pool and free list. Okay, now we have stored everything inside pool. Now we can give the address back. So now we can give it back to the pool's free list. So it will be something like this. Let's check. Okay, we are here pool free. So check parameters, change pointer from void to free block. Yeah, we did that. Add size in block. Okay, we did that. Add next and add next address. We did that. Change free list address to new block. So that's what we did. So let me explain it to you. Now first it's pointer to void. We made it pointer to free block, so that made it save size and next, so we can save size and next in it. So we saved size from pool block from pool. So we have object size in pool, so we saved that, and we also have the current free block address in pool as well. Okay, so we get that free list address and we save that as next inside this block, and then we added this block's address to free list. So we again made that chain as it was. The next function is, I guess, pull destroy. Yeah, pull destroy. It's nothing, you can do it too. So pull destroy. Now what are the pull allocator? Pool Okay, now what we have to do is we have to check pool. If it's equal to null, return null, otherwise free the pool memory, and then we have to free the pool itself, like this. So you don't have to worry about checking pool memory is equal to null or not, because even if you did free something like this, okay, C doesn't gives you any sort of error, so GCC compiler doesn't gives you any sort of error, or any other compiler for that matter. So you can do this, it's legal. Okay, but yeah, that's what we're doing. And yeah, like that, full destroy is also completely done. The next thing is memory utils.c. Memory utils.c. The next thing we have to build is this align pointer, which I think just returns the aligned address. Yeah, so let's do that. Before doing that, let me just include common.h. So yeah, now let's build a function. So it returns pointer to void. So it returns pointer to void align address, no, align pointer. Okay, align pointer, it takes pointer and the other size of alignment, the pointer and the size alignment. So it takes the alignment. Okay, after that we have to check the pointer first. Pointer equal to null or alignment is equal to 0, return null. Okay, then we have to check if the alignment is power of 2. So alignment and alignment -1. If it's not equal to 0, okay, then we have to return null. After that we have checked the alignment as well. So now we have to get the aligned address, uptr, and then okay, so I have to make it first. Okay, let's just see here. There is just a second. Align pointer, check pointer alignment, change pointer to, yeah. So what I can do is something like this, pointer, and then we can change it like this and give the pointer. Yeah, so now we will get the aligned pointer. So it will be something like in pointer plus alignment -1, and then I have to use AND operator with and something like this, -1. Yeah, so now we will get the okay, why am I getting the error? Yeah, so yeah, so by this we'll get the aligned address. So what we have to do next is align address, yeah, change align address to void and return it. So yeah, we have to do nothing except make it pointer to void again, and then pass that aligned pointer again, something like this. So align pointer is done. So the next is check malloc. Checked malloc. Okay, it returns pointer to void and it gets size. checked malloc and it takes pointer to void, something like this. So first thing is we have to check, no I guess, no, it doesn't take pointer to void, it takes the size. Yeah, it takes the size, something like this. So we have to check if size is equal to 0, then make the size 1. Okay, after that, now once we've checked the size, made us check the size, we have to give it memory. Okay, we have to allocate memory. So memory malloc and then the size. If we have to check if memory is equal to null, in that case we have to return null. Okay, now next thing which we have to do is, okay, checked malloc. Where's checked malloc? Yeah, here we go. Checked memory, add memory stats values and return address. So there's one thing which I forgot to add. So there's one more struct we have to add in where allocator. Yeah, in allocator.h. So I forgot to add that. So let me add that quickly. Okay, so now I'm going to create a file. So in include, we have to create one more file. So there are change of architecture going to be. So memory.h, and here you have to paste add this code. So this code you'll get on GitHub, so you can add that as well. Okay, so here we have this memory stats struct and some functions which are there in architecture already, so you don't have to add that. Now that we've got the struct, we have to update that struct according to this. After one memory allocation, what we have to add is total allocation size. Okay, so total, let me just close this. So now on top here I have to do one more thing, that is static will be memory okay, I have to include that. Yeah, memory.h, then here memory stats and create memory stats. Okay, now we have created a memory stats struct here. Now I'm getting error. Okay, static. So I have to update the values of that struct. So what we have inside, we have total allocations which will increase. So memories memory stats dot total allocation will increase, something like this. Then bytes allocated will also increase. Memory, okay, let me just copy this down. Okay, bytes allocated will be plus equal to size, and then current memory usage will also increase the same way. Current memory usage, and if so we have to peak memory usage, we have to check if current usage is greater than peak memory usage as well. So yeah, so if size is greater than memory stats dot peak memory usage, in that case I'm just going to copy this, paste here, and it will be equal to size. Okay, otherwise we have to do nothing, and then in the end I have to return the memory like this. So align address is, so checked malloc is also done. Now I don't think checked realloc is not necessary, but I will add it, and both the logics are same. So instead of wasting time here, I'll add it directly. So now the only two things which I have to do is check free and memory statistics. So yeah, let's do that. Now why the fuck, yeah. So here void checked free. Now it will receive void pointer, and let me check this in here. Okay, it will receive void pointer and size. Now we have to check if ptr is equal to null, then return. Otherwise, okay, let me just check in here. Okay, if we check parameters, free ptr change memory stats. So if size is equal to 0, okay, in that case I have to make the size is equal to 1. Okay, and then free the pointer, and then in memory we have to update the memory stats as well. So what we have in memory stats, total allocations, total frees will increase. So memory stats dot total frees will increase, and bytes freed will also change. Memory stats dot bytes freed will be plus equal to size, and yeah, that's all. Current memory usage will also decrease. Yeah, and there is one more thing, memory stats dot current memory uses minus equal to size. Okay, so not like this, minus equal to size. Okay, now this is done. The last function is memory statistics. Let's build that as well. It's going to do nothing, it's just going to return memory stats, pointer to memory stats, memory statistics, and it's going to get void, nothing. Let me just check, but okay, void, and here I have to return memory stats. So yeah, this is done. So we built the memory folder totally. Just one function is remaining, which is checked realloc, which I'll add. By the time we'll see the video, the function will be there on GitHub. So yeah, that's all.